Hello students, so here we are with the question second of the exercise 4.4 for the chapter Quadratic Equations. So the question second is find the values of k for each of the following quadratic equations so that they have two equal roots, and the two quadratic equations have been provided in parts first and second. Coming to the first part here, the quadratic equation being provided is 2x square plus kx plus 3 which is equals to 0. Now comparing this quadratic equation with the standard quadratic equation, what was the standard form of the quadratic equation? Ax square plus bx plus c is equals to 0. So this was the standard form of the quadratic equation. So comparing this quadratic equation with the standard form, here a is equals to 2, b is equals to k and c is equals to 3. And as we know, in order to have two equal roots of any quadratic equation, its value for the discriminant will be equal to 0. And what was the discriminant? Discriminant was b square minus 4ac, which will be equal to 0. So substituting the value of the b, a and c in this discriminant formula, so here I will be getting k square minus 4 into 2 into 3 which will be equal to 0. So calculating it, I will be getting k square minus 24 is equals to 0, or I can write it as k square is equals to 24. Now taking the square root on both the sides, here k will be equal to plus minus root 24. That is, two values for the root 24 is possible for having k variable. That is, k can also be equal to root 24 or it can be equal to minus root 24 as well. If I simplify this root 24, then it can also be written as k is equals to plus minus 2 root 6. Means the two equal roots which this quadratic equation will be having are, or I can say the value for variable k for which two equal roots have been obtained for the quadratic equation 2x square plus kx plus 3 is equals to 0 are k is equals to plus 2 root 6 and k is equals to minus 2 root 6. So these are the values of the variable k, which is b in this form. Now coming to the second part here, the second quadratic equation being provided is kx into x minus 2 plus 6 is equals to 0. Simplifying this, I will be getting kx square minus 2kx plus 6 is equals to 0. Comparing again this quadratic equation with the standard form, that is ax square plus bx plus c. So from here, the value of the variable a will be equal to k, b will be equal to minus 2k and c is equals to 6. So these are the value of the a, b and c. Now the next step will be to find the value of the discriminant, which will definitely be equal to 0 as the quadratic equation has equal roots. Substituting the value of the b, a and c in this discriminant formula, so here I will be getting minus 2k whole square minus 4 into k into 6 which will be equal to 0, or I can write it as 4k square minus 24k is equals to 0. Taking 4k common from both the terms, in the bracket I will be left with k minus 6 which will be equal to 0. So the two terms will be equal to 0 if either of the term becomes 0, that is, it might be the case that 4k is equals to 0 or k minus 6 is equals to 0, such that their product will definitely become 0. So from here k will be equal to 0 and from here k will be equal to 6. So the two values for the variable k in this quadratic equation such that the quadratic equation have equal root comes out to be 0 and 6 respectively. So this was about the question second of the exercise 4.4. I hope this question is clear to all of you.